Coming up on a minute, not tracking any holds on the board right now. So as long as we don't have any last second things, which do happen. All right, flight director just confirmed T-minus 1 minute. Key moment to look at in 10 seconds, that T-minus 40. And we flew right through that.
Flight directors go for launch.
All right, we're now T-minus 20 seconds until liftoff of Flight 6, as well as
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Vehicle is pitching downrange.
Booster Raptor, chamber pressure nominal.
Booster and ship, avionics, power, and telemetry nominal.
All right, we're just a little over a minute
maximum
into flight.
Dynamic pressure.
We're about 6 miles away, so all the sound's still hitting us here. Hearing good call outs that power telemetry nominal, that's flying straight and true. We do see all 33 Raptor engines lit up on telemetry screens. At this point, we've passed through that point of maximum aerodynamic pressure, that max Q. Now coming up in just a little over a minute from now is going to be hot staging. So we're going to see the 6 engines on the ship ignite while still attached to the booster. Just before that, we'll see all but 3 center engines on the booster shut down. In what we call MECO, it's most engines cut off instead of main engine. And so while we continue to watch it go up, a lot of our flight controllers looking at all the systems around the tower. Again, we have to send a manual command. Just about 30 seconds away from hot staging. And we heard the tower is go.
Booster engine cut off.
The return flag is set for true.
Ship engine start up. Stage separation.
All right, hot staging confirmed.
Booster
6 out of
boost
6
back
lit on the ship. Booster boost back going. We heard that we are go. Kate, Jesse, take the views. Hopefully I got a booster coming home real soon.
Wow, from our view here, Dan, great views of planet Earth behind that super heavy booster. Right now it is performing the
Ship
boost
chamber
back
pressure
burn.
nominal.
good news there, telling us that the pressures inside the ship are good. That is the second stage, or the upper portion of the vehicle. Follow along with the telemetry on the bottom of your screen.
Yeah, booster is currently, Super Heavy is currently in its boost back burn. This boost back burn,
Avionics, power and telemetry nominal.
this boost back burn lasts just a little bit over a minute. So we've got a little, approximately 30 seconds left.
We've had shutdown of that boost back burn. Up next will be hot stage jettison. The view from the camera on the left, or from the booster on the left-hand side of your screen, and then tracking cam there on the right-hand side of your screen. We'll see those grid fins.
Booster offshore divert.
And we can also see that the hot stage has been jettisoned.
Yes, visual confirmation of that there on your screen, which is great. The next step for booster is going into that landing burn. Again, it'll light up 13 of those engines and then pare down to 3 engines right before.
All right, now just real quick, we did hear the call out, booster offshore divert. Unfortunately, that means that we are no-go. As we said before, both the tower and the vehicle, as well as the operators on console, have been actively evaluating the commit criteria for that return to the launch tower. And unfortunately, we did not have a pass on those commit criteria, so we are no-go.
And we did mention that we're constantly evaluating the criteria. There's a lot of things that need to go well in order to line that up. Unfortunately, today we will forego. But what you're seeing on your screen is ship currently making its way towards the exactly. And we're still going to get a lot of good flight data with booster even, but especially with ship. Again, we have an additional objective today to do an in-space relight of a Raptor engine, which again will help us set us up for being able to do deorbit burns, which is
Ship chamber pressure is nominal.
which is important for orbital flights. And what you're seeing on your screen is a view from Super Heavy as it's making its way back down to Earth.
Yeah, once again, we are attempting an offshore landing of the Super Heavy booster. So we have seen this before, and it is still very fun to watching it come down for a soft splashdown. We can see it there re-entering. We saw earlier those grid fins. There are 4 hypersonic grid fins. Oh, we can see that the landing burn has begun on the Super Heavy booster.
What an incredible view of splashdown that we got today of Super Heavy.
Yeah, I'm sure the buoy cam views will be pretty awesome once again. So we'd like to confirm a water landing once again for the Super Heavy booster.
Ship engine cutoff.
And there we just heard call out for SECO, ship engine cutoff. Great news there. Everything continuing to look awesome for ship.
Full view looking aft on ship here.
Ship FTS is saved. Nominal orbit insertion.
There's that call out we were waiting for. Confirmation of good orbital insertion for ship today.
It has been a very exciting afternoon so far. We'd like to send it back over to Dan, who can give us that live view experience. Dan, once again, are you okay after witnessing another launch?
Yeah, totally fine. You guys have to be jealous. This is the only way to do this. This is fantastic. No, it was really cool to see a liftoff, 33 out of 33. Didn't go for the booster catch today. Initially, we were good, and then we tripped a commit criteria and did the offshore divert. So we went and did that water landing, as everybody saw. We'll dig into it a little bit more, but again, this is We've done it once. We've now done it twice. We're going to keep trying to do it, as this is just a core capability and what's going to make it so incredible. There's a lot left. We're just about almost 10 minutes into this flight, so about 50 plus minutes still to go. Ship nominal orbit, so it's on its way around the planet. It's going to attempt to do an in-space burn. We're going to light one of those Raptor engines, the sea level ones in the middle, just to help demonstrate that we can relight in that microgravity environment. Really critical for deorbit burns as we start to do some orbital missions in the not too distant future. And then following that, we'll see a ship entry, maybe a splashdown. As you guys said, we're really going to be pushing ship on this one. We're pretty much intentionally putting it in places where we expect it might not do so great, and all that's to try and help us learn, see if we were a little too conservative, and then maybe that opens up more capability for when we start catching them. But I'll check back in with everybody in a little bit. I'm going to tune in and watch the ship fly around planet Earth, and hopefully we see it re-entering in the not too distant future. Back over to you guys.
Thanks, Dan. Development testing, by definition, is unpredictable, which we saw with Super Heavy splashing down. That is exactly why we test. As is standard for these tests, the area around the pad and along the flight path was cleared prior to launch, and we expect the road and beach to remain closed until further notice.
Yeah, testing development flight hardware in a flight environment is what enables our teams to quickly learn and execute design changes and hardware upgrades to improve the probability of success in the future. Please do not attempt to approach the booster in the water for your safety as well as for that of our team that will be working on recovery. Now, we are going to continue though. The mission is not done.
Exactly. The mission's not over. Ship is still coasting, but it has been nonstop since liftoff, and with the booster having completed its job for the day, we are going to take a short break for the next 35 minutes or so while ship continues to coast before re-entry.
So if we do have views, we will be sure to bring those to you live. And of course, one of those views include that of our, as we said before, surprise payload, the Banana. And we are looking forward to it. So we're going to come back in a few minutes, around T plus 35 minutes.
Exactly. Views or no views, we'll see you back here at T plus 40 minutes for re-entry, flip maneuver, landing burn, and hopefully see a splashdown.
are just about 35 minutes into today's flight test, continuing to get some live views as it continues to make its way around the globe. We are coming up on what we will hopefully see is our in-space relight demonstration. This will be firing up one of those 3 sea-level Raptors on the very aft end of the ship and essentially reigniting it while we're in that microgravity environment in Earth orbit. We had attempted this once previously on Flight 3, but ended up skipping it when we had some attitude control issues with the ship. And we are on the dark side of the planet right now, so views are going to be a little bit dark, but hopefully we see some engine light come on as we do this relight test. This is a pretty critical capability for doing deorbit burns. This is not a deorbit burn. Want to stress that we're on a trajectory where if we didn't fire off the engine at all, we are definitely coming home. Ooh, seeing some thunderstorms down on the ground. That's pretty cool. But this is not a deorbit burn. If we didn't fire this engine, we're on a intentional suborbital trajectory. About a minute. It's just going to be one of these engines, and it uses what's called the header tank. So these small spherical tanks in the very top of the nose cone. They don't require nearly as much gas to pressurize as your main tank, so they're really useful for any in-orbit maneuvers. And then for landing burns. So if we make it to a landing burn today, we'll be using them for that as well. So we should be coming up in just about the next minute. Should be under a minute now away from that expected ship burn. And again, we've relit Raptors pretty frequently. We just did it with the landing burn and that boost back burn on the booster, and we've done it on ship landing burns. We just haven't done it in this microgravity environment where your propellant management and a lot of other things are different as you're not weighed down by the force of Earth's gravity.
And
just heard the call out for startup. There's some light. There's that Raptor relit. And shut down. All right, there you have it. The first time ever lighting a Raptor while in outer space, other than our ascent burn. So really cool to see that relit. That's a pretty critical capability that we're going to need when we're doing orbital missions in the not too distant future. So check another one off. That was a really cool. That was an objective we really wanted to hit on this one, and so good to see ship knock that one out in orbit. But for now, we're going to coast for just a little bit longer, and then it'll be time for ship entry. So we'll get the usual light show as we return from hypersonic velocities. We're just starting to do the entry prep for that, so we're going to get the flaps positioned, and then it's going to start taking the brunt of all of that heat as you're coming in from well in excess of 10,000 miles an hour. That's all going to build up a lot of heat as you're encountering an increasing atmosphere, building up that friction. And we're going to see how the tiles fare. We've also got some pretty cool tile experiments that we'll talk about in a little bit. But coming up real soon, ship re-entry, successful relight, and we'll start this entry part soon.
Starship is at 100 kilometers altitude, good attitude for atmospheric entry.
Welcome back.
The ship, as you can see, is beginning to re-enter the Earth's atmosphere. As a reminder, one of the main goals of today's flight test is for the ship to make it through the extreme heat of re-entry and to do so in a controlled manner. Now, re-entry is typically a portion of flight where we don't have communication capability with the spacecraft because it's re-entering at or around orbital velocity, which is roughly 8 kilometers per second or about 5 miles per second. Now, at those speeds, pretty fast. The spacecraft is moving through the atmosphere rather quickly, and that results in friction, as we can see that starting to happen on our screen, and this creates a plasma field around the vehicle. That blanket of plasma distorts communication frequencies, so it's not uncommon to experience brief blackouts in communication.
Do really want to stress that we are really pushing the ship today. The heat shield is not in the same configuration as it was last flight, where we had a team of ship techs do just an otherworldly task, replacing the entire heat shield, thousands of tiles, installing a backup ablative, and that pretty much set us up to do a pinpoint landing on Flight 5. We did not do that with this one. We have some backup in those really sensitive areas around the flat, but this is an older generation heat shield. And knowing we weren't going to do that, we even went and removed some extra tiles. There are some missing tiles on the nose cone where we're testing some backups. There are some steel-covered tiles in a couple of different spots, and there's also a whole lot more steel of the ship showing. As you guys talked about, we gave it a little bit of a haircut, a couple hundred tiles trimmed off the sides, and that's where we might have catch fittings in the future. But color's starting to come in, so it looks like things are going to start heating up, Kate and Jesse.
Yeah, fun fact, Dan, we actually removed 2,100 heat shield tiles in order to basically present that necessary receding line, which you kind of can see there in your view. Think back to previous flights. the heat shield line came up further on the vehicle. And just like Dan said, we want to test the vehicle beyond what we think it is capable of carrying based on our simulations and calculations. So once again, to just be super plain, don't be surprised if we see some wackadoodle stuff happen here. We won't be. There are a number of things that we are testing out intentionally to see what the ship can take.
Yeah, exactly. And knowing what those limits are will really help us design the vehicle of the future. Essentially, removing those tiles helps us remove a lot of weight from the vehicle, a lot of things that might potentially need refurbishment in the future. And the goal is to come up with a heat shield pattern or design that we don't have to refurbish. We can just continue to use it over and over again. And that's why we're changing some of those tiles and moving stuff around, removing a lot of those tiles, as Kate has been mentioning.
Oh, I was just going to say, like, there's so much on this flight that we're doing to try and, make all the ships that we're about to start flying even better, just really understand what their capabilities are going to be. We've got kind of the next-gen ship lined up for Flight 7. It's got all of those heat shield upgrades and everything. And one of the things that we're going to be doing that's most interesting, and one of the reasons we wanted daylight, is we're going to be flying pretty aggressively as ship comes in. We're going to be kind of nose down, and we've done it in wind tunnels. We've done it in simulations. You might see the flaps really flapping around, trying to control the vehicle. We're betting we might have a little bit more capability than we think in just the analysis, but always a chance that bet doesn't pay off. But that just helps us know, like, what are our...
Halfway through the peak heating phase of entry.
Sweet. Halfway there. Halfway home, guys.
Yeah, and if you guys, again, can follow along with the altitude and the speed of ship as it's making its way back down to Earth, bottom right-hand corner of your screen. Speed is still going really, really fast. Again, as it gets closer to Earth, we'll see that altitude drop a little bit faster. It's kind of dropping pretty slow right now. And again, as we get closer and closer to literally the surface of the water, then we'll start to see that speed pick up. And if we can make it through this re-entry, we will attempt to do that flip maneuver once again and splash down in the ocean.
Exactly. Like we've been saying, we are testing beyond the perceived limits of the vehicle. We want to go learn more about the ship, and this is a great opportunity to do that. So really pushing the flight hardware in a flight environment to help inform these future designs. As we've mentioned, it has a different heat shield. This heat shield is not the same generation as what we flew last time. This one is one generation older. So we are also testing out new secondary thermal protection materials. So basically, like, if the heat shield isn't in this one spot, can this other material protect the metal is the thinking there. Also, checking of the ship's structural strength in those areas where we're looking to add that ship catch hardware just to see if it survives entry. So yeah, as we've been saying, we've done a lot of calculations and simulations.
We are pushing the limits of ship today, but so far everything is looking pretty nominal. We'll see how the next few minutes goes.
Yeah, like we've said before, don't be surprised if this is not entirely smooth sailing all the way down to the ocean's surface. Similar to Flight 5, we are targeting the same splashdown location in the Indian Ocean, but we are not expecting to recover the vehicle.
Right, and we were getting some glimpses of the flaps. The flaps so far are looking pretty good. We're not seeing any burn through. There's those flaps again in that hinge area, which is our most concerning area there. That's great news for us for now. Again, the next few minutes could change as we continuously push those limits.
Yeah, once we slow down a little bit, once we're subsonic essentially, so I think that's about 1,200 kilometers an hour. Once we're down below that, that's when we're going to kind of dip our nose down and get that more aggressive angle of attack. Normally we're just belly flop right into the water, pretty much, that position. But if we're going to be able to do return to launch sites, we're going to want to be able to fly with a little bit more of an angle of attack, get you a little bit more range as you're coming through. And so this will be just a test to see quite how far can we push it. And obviously we're going to do these kind of tests way out here in super remote areas before you ever try to bring a ship back. And as we get down a little bit lower, the Raptor engines are in their chill phase right now, so just essentially getting them primed to turn on. We're going to use those 3 center engines to do a landing flip and then a landing burn. So we'll come down kind of in that slightly pointed down belly flop and then fire off those engines to flip us around and then do that final landing burn. That should be coming up in just under 5 minutes from now. And then hopefully we start hearing some call outs on transonic and subsonic as we slow down.
Yeah, this is such a cool view. This reminds me of when we first performed the belly flop maneuver on the high altitude test with serial number 8. We saw the ship come back through, and I always wondered what it looked like from the ship's perspective, and this perspective, I think, helps inform that. We will be, as Dan said, we will be dipping down a little further and really be flying nose first. This higher angle of attack, we're intentionally doing it to stress those aft flaps, and that will help inform the limits of flap control in order to collect data for future landing profiles. I have a feeling this is going to look so cool as it passes through the clouds.
Obligatory shout out to the entire avionics team on Starship.
And there's that nose down orientation.
Now the Raptor engines will relight and help flip the booster back up. This is a more severe flip given the orientation. The engines will shut down prior to the water making impact, prior to the vehicle making impact with the water.
Our ship is doing great so far.
There's
those engines relighting.
What a great reorientation.
Wow.
All three down to 2 into the water.
Wow.
And we have ship splashed down.
Some awesome buoy cam action here. Daylight
our buoy.
views.
Incredible. We really pushed the limits on shipping and made it all the way back down to Earth.
I am shocked, to be honest. I think many folks are. The fact that it survived all the way through while flying a lesser gen heat shield is just absolutely incredible. And turns out the vehicle had more capability than our calculations predicted. And that is why we test like we fly.
Exactly why we do that. And those views were absolutely incredible to watch.
We want to, unfortunately, wrap up the show.
Yeah, exactly. We'll say congratulations to our teammates at. Now, be sure to.
Hey guys, I could take it from here. That was just incredible to see that splashdown. As you said, thanks to everybody that took such a huge part in this.
Thanks to all of you for tuning in, and we'll see you next time.